This talk is about the D3 package, our new package that we introduced in ExtJS 6.5 this summer. So hopefully by the end of this talk you'll have a very clear understanding of how our package can help you with your data visualizations, even if you've never used D3 before. As you probably know, in the recent years there have been a lot of interest in D3, both in and outside of ExtJS community. Companies like Microsoft are using it for their research and development and for their business intelligence platform. Companies like Square are using it to analyze risks. And of course, companies like New York Times are using it to present interesting facts in breathtaking ways. So in other words, there's lots of people who love using D3 and have lots of experience using it, and so it's only natural then that they want to bring this experience to ExtJS world without too much hassle. Yes, we have a powerful charts package and its underlying draw layer, which combined allow you to do many different things. Still, as you will see, having another extremely popular library at your disposal is useful. So with that said, the D3 package is not meant to replace the charts package. It offers a set of unique components that have no parallels in the charts package. So there's just no feature overlap. So everything starts with the XD3 component. This is an abstract base class for all D3 components. It takes care about sizing and data updates, as well as gives us a life cycle of a component. On top of that, we have the SVG and Canvas classes. The SVG class is meant to set up an SVG document for us, and the Canvas is meant to set up a Canvas element. They all have a bunch of extra methods and events to help us. Since D3 is primarily DOM-focused, and although it can work with Canvas, Canvas is kind of a second fiddle, so we build all of our own components on top of the SVG class. And those are the heatmap, which we'll look into later, and the hierarchy class, which is an abstract base class for components that implement D3's hierarchy layouts. And we currently have 4 of those: the tree, pack, tree map, and sunburst. And by the way, this chart itself has been visualized using our D3 tree component. So here's how they look in their most basic form. So on top of each image, you see the X type of the component that was used to generate it. Each of these components are meant to render a tree-like data, but each one has its strengths and weaknesses. For example, the D3 tree is very good at showing the hierarchical kind of relationship, but not very good at showing other kinds of relationships in your data. So how did we create these charts? So we start by defining a view model somewhere in our view. Then we proceed by defining an X type of the component, let's say D3 tree map. Then we bind the store of this component to a store in our view, in this case, the letters of the English alphabet. And then we simply cycle through other X types. So we just replace the D3 tree map with D3 tree, D3 sunburst, and so on. That's how we got the images that you just saw. It's very simple. And this is the data that we used. It's just a tree of objects with the name field and the data children array. We also have expanded through on the non-leaf node to give a hint to our tree store that we want the tree expanded by default. Only expanded nodes are rendered, so when you're interacting with the component, for example, like double-click on a node, it expands and the tree re-renders. So to review, this is the config that we used. This is the data that we have. And this is the result we got. And you probably noticed that there is something missing here, right? We have the name in our data, but nowhere in our config would tell it to use the name, to fetch the name from the data. And that's because the name and text fields are the defaults. So by default, we'll try to fetch the value of the name field when that is empty or not found, we try to fetch the value of the text field. And if that is empty as well, we'll just return an empty string for the label. So the text will be invisible. You can set it to any value you want, or to any field you want, or it can even be a calculated value. So for example, you could fetch the first name and the last name of a customer from your tree store record, concatenate that, and return that as a label. There might be a little problem with this approach if the label is too big and your heatmap tile, for example, is too small, the label won't fit into the tile, or if you're using a tree component, the labels can start to overlap. So in this case, the tooltip config to the rescue. It's just a regular tooltip, just like in any other ExtJS component. So all the same configs that can go into a tooltip can be used here, like show delay or track mouse. It only has one extra property, and it's the renderer function. It's meant to fetch the data from your model and set tooltip's HTML grid. So in this case, we're fetching the value of the hint field from the model. And now when we hover a node of a tree, we get a nice little tooltip. In this case, C is for cookie. Now some already may know that, which is why tooltip is perfect here. All the three components are meant to work well with data binding. And so before we jump to a quick demo, let's take a look at the full code for our view. Again, we start by defining a view model. Then all our components, just like that, only X type, because they will all have the same configuration. Then we will bind the store of each of the components to the same store in the view model. And we'll also bind the selection config of each of the components to the selection config of the rest of them. And the tooltip config is the same one you saw on the previous slide. So let's take a look at how this works in action. Not what I expected. Let's do this. So when I hover the nodes of a tree or any other components, you can see that I get a tooltip for every one of them. And also, as I select a node in one of the components, it is selected in the rest of them. Also, if I collapse a node, it is collapsed everywhere and expanded everywhere. So it all happens in sync. All right. Now, I'd like to emphasize that even though hierarchy components are predominantly meant to be used with hierarchical data, they can be helpful even if you have no hierarchy in your data. So in this case, we have a flat array of objects that have a name field and a frequency field, where the frequency field corresponds to the rate of occurrence of a particular letter in the English alphabet. And so we could use something like treemap to render this data. So this should be a familiar config, except for the one extra bit, the root visible false part. And we have to do this because nowhere in the data we have an explicit root. And the way tree stores in ExtJS work and the way hierarchy layouts in D3 work is that you must have a root, and that is why an implicit root is always created. So it's always there, even though the data does not have it. So we want to hide it from the layout. That's why we use this config. So the image that we get by doing this looks like this. So each tile corresponds to a letter, and each tile has an equal area. And this is because we have another config that is responsible for the size of the node, and it's node value. So the default for this config is 1. It's actually a function that is meant to return a value that will be used to determine the size of the node in a hierarchy layout. So this is a shortcut. So 1 will be converted to a function that will always return 1. But let's say we set it to something like frequency. In this case, this will be converted to a function that always returns the value of the frequency field. So that is what will determine the size of the node from now on. And so this is the result we get, which is, well, makes it pretty clear that E letter is by far the most popular letter in the English alphabet. And another thing that you've probably noticed is that each of the tiles has its own unique color, and these are 2 changeable. So this is done by the means of the color axis config. It has 2 main components: the field name, it's basically the value that you want to colorize, and the scale function, which is how you want to do it. So by default, we use the ordinal scale, and this range config with the value that is the cryptic string scheme category 20C is actually one of the predefined themes, color themes, in the D3 package itself. So the way an ordinal scale works is, well, or any scale works, it maps a value from an input domain to an output range. And so in this case, the output range is an array of colors, and the input domain is all the letters that we have. So each letter is assigned a unique color until we have so many letters that we start running out of colors, and then we just start to reuse colors. So that's how we get this image. And so far, you know, there's been like the child's play to warm up to more serious stuff like the stock market. So with a bit more tweaking, you can get a result like this, just tweaking the configs I just described. So this is a performance of the companies in the services sector, visualized by the tree map component, where each tile corresponds to a company and the area of each tile corresponds to its market cap, while the color of the tile corresponds to the change in performance since previous close. The label of the tile is a ticker symbol of the company, and the tooltip that you have is extra information like full name of the company and exact amount of the change since previous close. And so we did this by configuring our color axis slightly differently. We fetched the value of the change field, and we changed the type of scale from ordinal to linear, and the domain and range are slightly different. So we want negative change of -5% and below to correspond to the red color. We want no change to correspond to light gray color, and a positive change of 5% and above to correspond to the green color. This is actually a polylinear scale because we have 2 intervals, one for the negative values and one for the positive change in our range and domain, and any value in between -5 and 0 or in between 0 and 5 will be interpolated to a shade of red or a shade of green. You probably also noticed that the sector tile has light gray color, and this may be for different reasons. For example, you don't have the data for the performance of the sector, or maybe you don't want to colorize the sector tile because you think it might be confusing to your users. Either way, you need some custom logic to achieve this behavior, and this can be done by the means of the processor function. The processor function is given a bunch of different parameters, including the scale that we just defined above and the field name. And what we can do is we can fetch the record that is associated with the tile, check if it's a leaf node or not. If it is, that means it's a company, not a sector. And so we can get the field value from our model, pass it to the scale function that gives us a color, or if it's a non-leaf node, it means it's a sector, in which case we want to use light gray color. Another possibility would be to calculate an average of an average performance of all the companies in the sector, like even if you don't have the data for the performance of the sector, what you could do in this else statement where we return light gray, you could fetch all the immediate children of the record, which would be the companies that are in the sector, calculate the average performance, and pass that value to the scale function so that you get a color that represents the performance of the sector. Okay, so let's take a quick look at how this works as well. So here we have the tree map component and a tree panel on the left, all bound to the same tree store. So when I select a node in the tree map, it is highlighted in the tree panel. And the opposite is also true. Also, if I collapse some node here, it is collapsed in the tree map. Or if I collapse this technology node, and I scroll down, sure enough, the technology node here in the tree panel is also collapsed. And I can switch the value of the node value config from market cap to like a 1. So like in this case, all tiles have same area, and this means that, well, we set node value config to 1, and if we set node value config to the market cap, the area of the tile corresponds to the market cap of the company. So tooltips also work. Perhaps I should minimize it. For some reason, tooltips are finicky in the full screen mode. So as you can see, when I hover over a tile, we get the full name of the company and the change from the previous close, the exact amount. I can also interact with this chart by zooming in, zooming out, panning. So you can see that the constraints are in place, and we also see scroll indicators. Also, in this example, we can see that we support elastic constraints, and we also support kinetic scrolling. So what I just showed you is called D3's interactions. It is very similar in concept to D3's behaviors. So why would we do our own interactions when D3 already has behaviors? Is because the D3's behaviors are incompatible with the AXC's event system. So for example, if you use something like touch action config and you want to prevent the whole document from zoom in, if you pinch zoom your D3 component, you have to use the touch action config, and the D3 has no notion of that. So another approach is needed. Also, we provide a bunch of extra functionality on top of D3's behaviors, such as kinetic scrolling or elastic borders that I just mentioned, as well as scroll indicators. So to add an interaction to your component, you would simply do something like interactions type zoom, and that's it. And you can also configure a bunch of various parameters of the interaction if you wish, like the gesture that should be used to trigger panning or zooming, or whether it should use constraints, and how much sprint tension should be for the elastic borders. So lots of options there for you. So another component that we have is the heatmap component. It's a very popular type of visualizations meant to render matrix values with colors. It additionally supports legends, something that we eventually will support for other components like the hierarchy components. So in this case, we render sales per employees per day, where the color of the tile corresponds to the performance of the employee on any given day. And this is the data that we used. So even though heat maps are meant to render matrices, the data itself is actually linear. So in your store, you would first list all the sales for Alex for every day of the week. Then you'll do the same for Nige, and then for the rest of the employees. And each record in the store will actually correspond to a tile in your heat map. So we configure this by doing the familiar thing, defining the X type of our component and setting its store to some store from a view model or not. Then we configure the axis. So we want to position the employee axis to the bottom. We use another type of scale, the band scale. And this is a bit confusing because in the previous version of the D3 component, you could simply use the ordinal scale. And this has changed in D3.4. So the functionality that was in the ordinal scale now moved to its subclass, the band scale. So you have to use that now. So just remember, if you have discrete data in your axis and you're thinking about using the ordinal scale, you now have to use the band scale. If you want to know the exact reason why that is, you can catch me after the session, and I'll explain the details. Then we set the text and font size of our title. And then we tell the axis to fetch its values from the employee field of each of the store records. And then we do the same for the y-axis. We just position it to the left, tell it to use different title and field name to fetch its data. And the color axis is configured in pretty much the same manner as in the hierarchy components. You tell it to use the sales field to fetch the values from. And again, we're using a polylinear scale, although in this case, we're not supplying the domain manually. So the domain will be figured out from the data. So let's say the employees with least amount of sales has 40 sales. So that will be the starting value of your domain. And the employee with the highest sales has 100 sales. So that will be the end value of your domain. And since we have 3 colors in the range, the component is smart enough to figure out that you want to use a polylinear scale. And even though you have 2 values in your domain, like minimum and maximum value, we'll get an average of that, which is going to be 70. And so 70 will correspond to yellow color, 40 will correspond to green, and red will correspond to 100. And any value in between will be just interpolated into a different color. Then we style the border of our tile. So depending on which colors you chose to use for your color scale, the color of the border may not match well with the color of the tiles. And so in this case, we're using the dark blue color, which seems to work well. And finally, we configure the legend. So the legend is using the same colors from the color axis. So you don't have to specify the field that it should use, the color scale that it should have. It's all automatic and implicit. The only thing you have to do is to position it, give it some padding, which is the distance, in this case, from the right edge of the heat map. And you also have to specify how many tiles you want to have in your legend. This number is only a hint, however, because legend will try to do nice segmentation. So it will try to have the labels be a power of 10, or like in this case, an increment of 10. So, so far what I've described is heat maps with a discrete axis. So we have discrete data in our X and Y axis, and actually continuous data in the color axis, the numeric values. But heat maps can be used with discrete data in the color axis as well. So color axis may render categories. So each category may be assigned its unique color. And the opposite is true. So X and Y axis can be used with continuous data like time or quantity of something. Tooltips are supported as well, just as with hierarchy components. Let's take a quick look. So this is a heat map component with a continuous axis. Let me just zoom out a little bit. And we support nice transitions, so when you change the size of the component, the tiles in it animate. You can also configure the type of animation that you want to use. So, for example, this is just an is out function that is used to animate the tiles, but it can also be a bounce function. You can use elastic function to do your animation. And all the animations are staggered, which means that there is a slight delay between the animation of each tile, but if you don't want to have the staggered effect, if you find it confusing, you can disable that, and you get a nice animation like that. So far, what I showed is how to use our built-in components. Wouldn't it be interesting to see how hard it would be to create something like an org chart by subclassing our D3 component? But before I do that, I'd like to ask you a great question. How many of you have a clear, good recollection of how D3 selections and data joins work? Okay, so not many. Right, so let's quickly go through it. So a D3 selection is simply a transient object that holds a reference to the selected element. So in this case, we're selecting the body element, which gives us a selection that holds the body element. And a selection has a bunch of useful methods on it for DOM manipulation. For example, it has a select all method. So what this statement does, it selects all div elements within the body element, and so the resulting selection holds a reference to those elements. Another element that the selection has is the data method, and this is what actually produces a data join. It takes the elements passed to it, and it joins the data to the selected div elements. So the result of that is an update selection. It's those elements that have been successfully updated with new data. The update selection is a special type of selection in the sense that it holds references to two other selections. The enter selection is basically the dummy nodes that have no representation in the DOM, but for which data exists. And the exit selection is the nodes that have no new data associated with them. So let's say initially we had no div elements in the body element whatsoever, and we did this. We selected all the div elements, which gives us an empty selection. So no elements there. We used its data method to produce a data join, and we asked for the enter selection, which is 5 dummy nodes, which have like no DOM elements associated with them, and we used an append method on that selection to actually create the div elements and put them into the body element. And what happens under the hood is that those elements are assigned a datum in the double_data property. So the actual data is not stored in the selection, it's stored on the element itself. Another thing I'd have to do is to quickly explain how D3's hierarchy components work, and now that you know how selections work. So D3 has a bunch of layouts, in this case hierarchy layouts. So D3 tree is one of them. So this is how we create a layout in D3 natively. So before the layout can do its thing, we have to process the data of a tree store so that the layout understands the format. So D3 hierarchy is how we do that. So we process the data, then give it to the layout, and then the layout returns a layout root, which is the root element of the layout that has the position and size of the node that corresponds to this tree store record. And the layout root has the descendants method. So what it does, it returns the layout root itself and all the children in it. And the nodes is actually just a flat array. It's not in a hierarchical format. And so we then select all the node elements within our scene and create a data join by using the data function. So this gives us an update selection. And again, from the update selection, we can get the enter and exit selection. So we fetch all three and pass each selection to its own function. So add nodes, update nodes, and remove nodes. So we'll actually be subclassing the add nodes and update nodes methods to produce an org chart. So the data that we have looks like that. We have a name of a person in the company and an image associated with that person. And this is the configuration for the tree. So this is if you used our standard tree, not the one we're going to create. So node size basically tells us that the size of the tree node should be fixed. By default, the tree will stretch to occupy the whole area of the component. So we want to prevent that in this case. We also configure an interaction and disable the double tap action because we don't want the tree to zoom when we double tap on a node to expand or collapse it. And so this is how this tree would look like. So let's start by subclassing our tree. So this should look familiar. So we just extend the horizontal tree. We give our component a new X type, in this case, SenchaTree. Then in the scene setup method of the component, which we override, we create a clip path for our image. So let's say we want not square images in our tree, but images with rounded corners. So we want to clip the edges of the image. So the way you do this in SVG, you create a clip mask in a special section of your SVG document. In this case, it's the def section, and we have a special method getDefs to fetch that. We append a clip path element to this section, and we append another element to it, the circle, which will act as the actual clip mask. And we set the radius of this circle to 45 pixels. Then in our add nodes function, so we receive the selection of the entering nodes, so nodes that have no representation in the DOM. What we do is we set the opacity of the nodes to 0 because we want to fade them into view and animate them into view by changing their translation. So we append an image element to that selection. So each node will be represented by an image. We set its URL to the URL of an image associated with the person. And we slightly position it to the upper left corner and set its width and height to 90 pixels. So the elements will be positioned by the means of translation, so we can use X and Y attributes to displace them from their initial position. And then we use our clip paths to indicate that the edges of the image should be clipped. And then in our update nodes function, what we do is we merge the update and enter selections because we want to change the node's position, whether they are edited or whether their data has changed. So we merge both selections, and we use a transition because we want to fade the nodes in and move them into view as well. And this means that all changes to the attributes of the selection will happen not immediately, but over time. So the opacity will gradually change from 0 to 1, and the translation will gradually change from the current position of the node to the position of the node in the new layout. And so the getNodeTransform function does precisely that. So we can just reuse it. And again, this is the same configuration, and the only thing that has changed is that we used a new X-type, the X-type of the component we just created. And so let's take a look at how this actually functions. So this is our org chart. As you can see, we have, again, tooltips don't work in full screen mode for some reason. So if I hover this image, we see that it's our CEO, our Landrer. This is our vice president, and so on. And I can interact with this chart. I can collapse or expand nodes. And again, you should see the fade in, fade out transition. I can zoom in or zoom out, and here is our scroll indicators as I pan around. So all in all, by just subclassing a couple of functions, we got a tree that looks very different from the original one. So what's actually new in this version of the D3 package? So first of all, it's based on D3.4, which came out this summer. So the code that you know based on top of the D3 package should be more future-proof. Another good thing about D3.4 is that there are less side effects. Selections are now immutable, and your data is not mutated by the layout anymore. There are new and improved APIs in both our D3 package and in the D3 library itself. And of course, we now have nice default animations for all D3 components. With that said, there are some breaking changes, and it's mostly not our fault. It mostly has to do with the fact that D3's transition to version 4 is not exactly smooth. And so let me give you a quick example. So what we have here is our ext configs. So the left-hand side is the D3 version 4, and the right-hand side is D3 version 3, the right-hand side is D3 version 4. And on the bottom, we have the actual D3 code that is generated as the result of us using these configs. So our end bottom, it's still the same, even though the generated D3 code is vastly different, right? It used to be D3 SVG axis orient left, and now it's just axis left. We managed to preserve compatibility. This part is different. Not only it says time day instead of days, so it's no longer plural. It now also lives in a different namespace. And time format function also lives in a different namespace. You may be wondering why we are wrapping these D3 statements in quotes, and this is because this thing will be evaluated at the time of the definition of your view. So at the time the ext-define function runs. And so at this time, we don't have any dependencies loaded, like we haven't yet loaded the components definition or the D3 library itself. So if you try to use D3.timeDay, for example, you will get a message that says D3 is undefined. So you wrap that statement in quotes, and it's evaluated later, and you no longer have this problem. So it was a tough balance, to give you as much power as possible by not wrapping, every API that D3 has into our own function call. So we expose the API, and I hope this is a good balance. So with that said, our components can be used to create any visualization you can imagine. So we have two classes that can be used directly, the D3 SVG class, aliased as D3, and the D3 canvas class. So to create a custom visualization, all you have to do is define an X type of the component, so X type D3, and then listen for something like scene setup event or scene resize event. And in the handler of that event, you would actually set up your whole thing. You can go to D3's official examples, pretty much copy-paste the whole thing, paste it into this handler, and that would be it. Actually, the only modifications that you would have to do is remove a bunch of initialization code from that example, because our D3 components already do this for you. Canvas does the same thing, but for the canvas element. It additionally provides support for resolution independence. So, for example, you don't have to, make your canvas twice the size, then shrink it down again with CSS, and then render everything, twice the size by calling, canvas context methods with, a factor of 2 or something. So this is all transparent, and this is done automatically for you. So let's take a look at a few custom visualizations that we have in our kitchen sink. So this is an example of how you can use D3's transition. So we are just using a spirograph function. We are calling it at a fixed interval over a certain range. It gives us, polar coordinates, which we convert to Cartesian ones, and then those coordinates act as the data for the positions of these tiny circles, and then we use slightly different parameters for our spirograph function to produce a new set of data, and then we simply transition the circles from the previous position to their new position, and we can use all kinds of easing functions to do this. We can use a function that gives us a bounce effect, or that gives us an elastic effect, and so on. The transitions here are also staggered, so there is a slight delay between the animation of each of the circles. And this is an example of canvas visualization. So this is a very simple particle system. And we use D3's timers here, and also D3's color scales to give each particle its unique color. I recently experimented with DOM-based visualization. So this is actually DOM, it's not SVG or Canvas. So all kinds of cool things that you can do. Right, and that's it from me. Thank you.